This is a study we carried out with a colleague, Alfonso Russo from Rome, who has processed the data statistically. This is my title, Aberrometry, a comparison between presbyopes and non-presbyopes. Why did we decide to carry out this study? Well, certainly presbyopia has a major impact on society. There is a recent publication that showed this and also stimulated the organizers to put this in the title of the Congress. In Italy, we have a considerable size of the population suffering from presbyopia, mean age 44.7, with a 3 lines increase over the past year. Then we have the clinical relevance of high-order aberrations. A lot has been said about them in optometry. I searched using high-order aberrations, and I came up with 60 studies. We have a lot of instruments available, and in the medium to long term, it is expected that aberrometers may replace auto-ref in clinics. Recently, optic devices were made available for managing high-order aberrations, including multifocal contact lenses. More recently, aberrometric control CLs with varying thickness. Some attempts were made also with spectacle lenses. Then IOLs, they were broadly discussed here as a way to control high-order aberrations. The goal was to compare the aberrometry pattern in presbyopes and non-presbyopes, both totally and corneally, to see whether there are any aberrations and check whether any correction strategies may be applied which are different between the two groups. Data acquisition was carried out with eye profilers' eyes. 82 eyes of 41 presbyopes and 82 eyes of 41 non-presbyopes were analyzed. Group creation. Non-presbyopes had to be aged between 20 and 35 with mean age of 26. Presbyopes had to be aged from 45 to 65, mean age of 52, standard deviation 0.5. Here I concentrated on creating groups which had to be as homogeneous as possible. Then there had to be no ocular disease, because some of them may in fact have a major role on high-order aberrations, and then a minimum visual guide of 10 lines per year to exclude amblyopia. In physiologic conditions, high-order aberrations are not significant if an eye sees only 5/10. Then no IOL implantation, because total aberrations could not have been compared. These candidates were not good for comparing corneal aberrations either. A recent Chinese study published results in 2014 showing that the incisions made to implant the IOL not only cause astigmatism, as we saw yesterday, but they can also increase high-order aberrations. And then other surgeries were excluded. For example, refractive surgery. Ametropy had to be included between -4 and +3 to have as homogeneous groups as possible. This is a study that shows that there is no relation between low and high order aberrations. In the spherical equivalent that we saw before, the cylinder had to be maximum 1 diopter. This study showed that astigmatism affects the amount of high-order aberrations. In the case of high astigmatism, there's an increase in high-order aberrations. Major astigmatism is always a sign of asymmetrical cornea. That's why this has a meaning. Choice of the pupillary diameter. You see 3 pictures of the same left eye here. It's a subject who's a non-presbyope in the study. Here, the first one to your left has 5 millimeters pupillary diameter, then 5 and 6.6. I removed data for 3 millimeter aperture. I excluded the maximum aperture because each subject can have a maximum aperture which is different from others. So everything we will see now concerns pupil diameters of 5 millimeters. These are the total and corneal high order aberrations that I have taken from the instrument. So trefoil, coma, astigmatism, and here you see the results of high order corneal aberrations. They all increase, some a bit more, some a bit less. However, there is statistical significance, which is only true for trefoil and coma, with statistical significance. For all the others, the value is a little bit higher. Here you see the results for total high-order aberrations. Here they all increase. Look at this spherical aberration. It has the largest aberration. It changes size. It changes a lot. Statistical significance is better here. Only the coma aberration has values above 0.05, while coma trefoil don't have such statistical significance. Therefore, the most clinically significant aberration has a level of statistical significance which is very high. In conclusion, I'll be brief because it's just me between you and lunch. In presbyopes, you observe an increase in high-order aberrations. Well, this is always true. This is affected by statistical values which are not so clear in all cases. Spherical aberrations are certainly the most exciting ones. Just a comment on the causes. I identified 3 factors underlying this phenomenon. As previously described, the tear film, which is quite worse in presbyopes than in non-presbyopes. Well, this justifies increased high-order aberrations, but not the type of variation of spherical aberration that we saw before. This can be caused by a change in the optic characteristics and shape of the lens. This changes a lot in presbyopes, as was witnessed yesterday. A study in January 2016 confirmed that the lens in the presbyopic age increases its thickness, the anterior curvature increases, the refraction index decreases, the anterior chamber is of a smaller size. All these changes may cause changes in the spherical aberration. And I also identified proximal or near accommodation as having an important role. The younger the subject is, for example, a 22-year-old patient in front of an eye profiler for data acquisition does a bit more of proximal accommodation compared to presbyope. And this may justify the negative aberration values found in non-presbyopes, because if accommodation is going on, the anterior curvature of the lens increases significantly, generating more negative total spherical aberration. Thank you very much.